In this video, we are going to review the material that we covered back in Unit 0 at the very beginning of the semester. So the first thing that we're going to talk about is simplifying radicals. So when we're simplifying radicals, we are looking at, we need to first talk about kind of the pieces of a radical. Alright, so when we talk about the pieces of a radical, you have your radical symbol, you have underneath what we call the radicand, and on the outside you have a tiny little number called the index. Remember that that index is going to tell you how many you're putting in a group, and if there's not a number there, it's an implied 2. So if you're looking at the first example, you have the square root of 147. So there's not an index there, that means it's an imaginary 2, and 147 would be our radicand. Now, in a perfect world, our radicand underneath the square root is always what we call a perfect square, which means that there's a number that we can multiply by itself to give us the number that's our radicand. However, 147 is not one of those numbers that's a perfect square. So what you can do is think about some things that are perfect squares, like 4. So if I took 147 and I divided it by 4, it doesn't divide evenly, which means that it's not going to be a perfect square, or I can't use 4. 4 is not going to be part of the numbers that will multiply together to give me 147. Okay, another one would be 9. So if I divided 147 by 9, it doesn't come out evenly. Okay, 16. Nope. 25. 36. Now keep in mind these are all our perfect squares that I'm trying. 49. 49 does work. Okay, so that means that 147 will break down to 49 times 3. So now I'm going to break 49 down. Okay, 49 breaks down to 7 times 7. 3 will not break down, so I'm going to leave it. Remember, your index tells you how many you're putting in a group, so we're looking for a group of 2 numbers that are the same. So the 7s are the same, so we're going to circle the 7s. And from that circle, we're going to take out one of the 7s to let it represent that group, get rid of the other one, and we're going to leave that 3 underneath the radical in the radicand because it doesn't have anything to go with it. So if we're simplifying the square root of 147, it will simplify to 7 square roots of 3. Radical operations is another thing that we covered in Unit 0. So with radical operations, you're going to either be adding, subtracting, or multiplying your radicals. So if you are adding or subtracting your radicals, you're going to look for like radicands and like indices, and you're going to be able to combine only if they match. So for example, in number 2, I've got 2 square roots of 3 minus 4 square roots of 3. So because both of these have a radicand that has square root of 3, then I can put these two things together. So 2 square roots of 3 minus 4 square roots of 3. I'm going to leave the square root of 3 and just deal with 2 minus 4. 2 minus 4 would give me negative 2. On number 3, square root of 7 plus 9 square roots of 7 minus the square root of 6. I can put together the first two because they have square root of 7, but the last one is square root of 6, and I can't put it with the other two. So I'm going to put together what I can. This is 1 square root of 7 plus 9 square roots of 7, which makes 10 square roots of 7. And I can't do anything with that square root of 6, so I'm going to keep the square root of 6. In number 4, 2 square roots of 5 times 3 square roots of 5 is a little bit different. When I'm multiplying, I'm just going to multiply the coefficients, the numbers out front, and then the radicands. So 2 times 3 will give me 6. Square root of 5 times square root of 5 will give me square root of 25. But notice that 25 is one of those perfect squares that we talked about in the beginning. The square root of 25 is 5, so this is really 6 times 5. And 6 times 5 would give me 30. On number 5, I've got 6 square roots of 10 times 2. So on this one, all you have to do is multiply the 6 and the 2 together. You do not put the 2 with the 10. So 6 times 2 gives you 12, 12 square roots of 10. Now, anytime you're left with a radical, you should always try to break it down. But if you think about breaking down 10, 10 would break down to 5 times 2. and neither 5 nor 2 will break down any further, so we actually don't have to do anything with that 10. However, if that 10 had been a 12, then we would need to break it down. All right, number 6, multiplying powers. We've got 4x y to the third times 7x to the fourth y to the second. When we're multiplying powers, we're going to multiply the coefficients out front first. So 4 times 7 gives us 28. And then when we're dealing with powers, we're just going to add our powers together. So if we've got x to the first times x to the fourth, that's going to become x to the fifth. If we've got y to the third times y to the second, that's going to give us y to the fifth. Think about it like the 4 and the 7 would obviously multiply together. You would say I've got 1, 2, 3, 4, 5 y's, or 5 x's, and 1, 2, 3, 4, 5 y's. When you're raising a power to a power, however, things are a little different. So if we've got negative 2x y to the third all to the second power, each piece inside the parentheses is going to get that 2 power. So we're going to say negative 2 to the second, x to the second, and y to the third to the second. So negative 2 to the second would be the same as like negative 2 times negative 2, which will give you positive 4. The x squared will just stay x squared. But if I've got x to the third to the second, that means I have 1, 2, 3 y's 2 times, which will give you y to the sixth. So the trick for that is multiplying the exponents. Okay? When you have negative exponents, you need to move your exponents to where they'll work. Now, the first thing you should always do is if you have, like in the case of number 8, we've got x to the negative 2 and x to the negative 2 on the top, and then we've got y to the third and y to the negative 2 on the bottom. If I can combine, I should go ahead and combine before I move things around. So if I have the same base, I'm going to add my exponents together. So negative 2 plus negative 2 will give you negative 4. On the bottom, y to the third and y to the negative 2 would be y to the 3 minus 2, or y to the first. Now, I can't have this negative exponent on the top, so it needs to come to the bottom. So if it was negative 4 on the top, when it comes to the bottom, it becomes positive 4. And that y will stay on the bottom because it was y to the positive 1. Now, I've moved everything from the top, so I'm going to put a 1 in its place to hold the place. On number 9, 6 times x to the negative 2. The only piece that has the negative exponent is the x, and so the 6 is going to stay where it is, but the negative x to the negative 2 is going to need to move. The first thing you should do, though, if you don't have a fraction, is turn it into a fraction. So I'm going to make this 6x to the negative 2 over 1. So having this over 1 now creates this fraction, and I can move this x to the negative 2 to the bottom where it will become positive, and I've eliminated my negative exponent. So a little bit more with exponent rules. On number 10, I've got 3x to the 8th over 2x to the second. Okay, now notice that the only piece that has the second is just the x, not the 2. So that means I have 3x to the 8 over 2x to the second. Okay, so I've got x's on the top and the bottom, which means I'm going to subtract. So think about it like having 1, 2, 3, 4, 5, 6, 7, 8 x's on the top and 1, 2 x's on the bottom. If I have x's on the top and the bottom, I can match up the x's, and that will leave me with 1, 2, 3, 4, 5, 6 x's. And those x's are on the top. Now, I can't divide 3 by 2, so I'm going to leave it 3 over 2. On number 11, 16x to the ninth over 4x to the negative 2 to the second. I'm going to leave the top as it is. The bottom, the only piece that's being squared, is the x to the negative 2. So that'll make 4x to the negative 4, because remember, when we have a power to a power, we multiply. The problem with this is I can't have these x's on the bottom, so they're going to need to come to the top. So that would be 16x to the ninth y to the positive 4 over 4. Now, my 16 and my 4 will divide out. That will leave me with 4. And if I have x to the ninth times x to the fourth, remember I add those exponents together, so that will give me x to the 13th. So my final answer would be 4x to the 13th. Now, on number 12, the top is going to stay as it is for now, but the bottom, each of these pieces is going to get this negative 3 power. So we're going to have 3 to the negative 3, x to the negative 2, or x to the negative 2 to the negative third power. Remember, I multiply when I've got a power to a power, so negative 2 times negative 3 will give me positive 6, and y to the negative 3 to the negative third will be positive 9. Now, the only piece that has these x's on the top are going to need to come to the bottom. So I'm going to leave that 3 on the top. I'm going to move my x to the negative 7 to the bottom to make it x to the positive 7. My x to the 6 will stay, and my y to the 9th will stay, but this 3 to the negative 3 will move to the top. Okay, 3 times 3 to the third, well, 3 to the third would be 3 times 3 times 3, which would be 9 times 3, which is 27, but I'm saying 3 times 27, so that's going to give me 81 on the top. Now, on the bottom, remember I'm adding my exponents if my bases are the same, so I've got 7 and 6, that's going to make x to the 13th and y to the 9th. So my final answer is 81 over x to the 13th, y to the 9th. Now, you can switch from what we call exponential form and radical form. So, remember that we talked about how a radical has important pieces. You have your radicand, your index, and then your radical symbol. So, for example, if I had the fourth root of x to the third, I can switch it around and change it into what we call exponential form. So, exponential form has a base and an exponent. But if I'm changing it from a radical to exponential form, I'm going to have an exponent that's a fraction. So my fraction is going to come from how many times I have the radicand. So the number of times you have the radicand over the index. So for example, in this one, my index is 4. My radicand is x to the third. I have in my radicand an exponent of 3, which means this is the times that I have this piece here. So my base is going to be x. My number of times I have the radicand will be 3, and my index will be 4. So the fourth root of x to the third will be x to the 3/4. Likewise, you can go backwards. So if you have a fraction exponent, you can go backwards and turn it into radical. So you'll have your radical symbol. Your radicand will be the x. The number on the top tells you how many times you have that x, which is 1. And the number on the bottom tells you what your index is, which is 2. Now, neither the 2 or the 1 are important here, because if I leave the 2 out, it's implied that it's a 2. And if I leave the 1 off, it's implied I just have x one time. And number 15, we're working with exponent rules and fractions. So what you're going to do is take something that looks like x to the 3 over 2 and divide it by x. Now, remember that if I have stuff on the top and the bottom that have the same base, I'm going to subtract those exponents. The exponent on this x is a 1. However, I have a fraction minus a whole number. So what I need to do is rewrite this so that I turn that 1 into a fraction I can work with. So if I'm turning this 1 into a fraction I can work with, I need it to have a common denominator to this fraction here, which means it would be 2. Now, I would have this as 2 over 2, because if it was x to the first and I want to turn it into 2, to make that over 2, I need to multiply this by 2. It was a 1. I want to multiply this by 2, and I need to multiply this by 2 as well. So it turns into 2 over 2. Now, remember, I'm going to subtract those exponents. So I'm basically going to have x to the 3 over 2 minus 2 over 2. And whenever I do 3 minus 2 over 2 minus 2 over 2, I'm going to end up with 1 over 2. So if I already have x to the a, that means my a has to be equal to 1/2. Okay? In number 16, I've got the 36th root of m to the negative 8 over m to the 4th. So the first thing I'm going to do is I'm going to rewrite this so that I move that negative 8 to the bottom. So this is going to be 1 over m to the 4th times m to the 8th, which means I would have the 36th root of 1 over m to the 12th. Okay? Now, just for the sake of being able to rewrite this, I'm going to make it the 36th root of m to the negative 12. Okay? So if I'm doing that, I want to rewrite it so that I've got my radical, or my rational exponent. So I'm going to say negative 12 is on the top, 36 is on the bottom. So negative 12 over 36 would reduce to negative 1 over 3. But I can't have that negative exponent, so I'm going to move it to the bottom, and I would have this. Now, I can rewrite that because m to the 1/3 would be the cubed root of m to the first. Negative and fractional exponents. So 1 over 2x to the negative 1/2. The piece that is has the negative exponent is the x to the negative 1/2. So I'm going to keep the 1 there. I'm going to keep the 2 where it is, but the x to the negative 1/2 is going to need to come to the top and become positive 1/2. X to the positive 1/2 would mean the square root of x, 2 and 1 over 2. So I can just rewrite that, though, as the square root of x over 2. In number 18, x to the 3rd minus 1 to the negative 1/4 power means that each of these is going to get that negative 1/4 power. So I'm going to have, if I have a power already and I raise it to another power, remember I multiply. So this is going to turn into x to the negative 3 over 4. And this will stay like this. Okay? Now, I'm going to make this over 1 so I can move my exponents because they're negative. And so I'm going to put, everything's going to move to the bottom. Then I'm going to rewrite them. However, the first one will stay, but the second one, the 4th root of 1 to the 1st, is just the 4th root of 1, which just means I need a number I can multiply by itself 4 times to give me 1, and that number would be 1.